Hey guys, welcome back to another video. In this video we're going to be looking at pixels and RGB, and so let's jump right into it. Can you guys guess what this image is? This digital image is something, but can you guess what it is? How about now? Now it's zoomed out a little bit. Zoomed out even further. Zoomed out even further. You may recognize this easily now as a smartphone icon for Facebook. Now guys, have you ever heard the term pixel before? How did you hear that term used? What do you think a pixel is? A pixel actually is the smallest controllable element of a picture that's represented on a screen. The word pixel is derived from the two words picture and element, but it's shortened and combined, much like bits or binary digits. When a digital screen is zoomed in very closely, we can see each individual pixel. In this image, a single pixel is circled in yellow. As you can see, there are quite a few pixels on this screen, each of which can be lit in millions of colors. However, pixels are typically composed of only 3 different colored lights. So which 3 colors make up the pixels on the screen in this image? We see red, green, and blue. Now look at how the colors of white and light blue in the Facebook image are different in the zoomed image shown here. So this area right here is the light blue area of the Facebook icon, and this is the white area. So how are those different? Pixels can represent the spectrum of colors by illuminating their red, green, and blue lights to different degrees. Zooming out, our eyes can't detect the individual pixels as easily, and we begin to blend the red, green, and blue lights into a gradient of different colors. So, how are pixels related to the quality of an image presented on a digital screen? And thinking about that concept, what do you think the term 1080p, which is also referenced as a display resolution, 920 by 1080, what do you think that means? It refers to the display device standard for full HD digital screens that are 1920 pixels wide and 1080 pixels tall. This equates to about 2.1 megapixels. So when you see the quality of a screen, it's talking about the number of pixels from top to bottom or from side to side. Most common color model used for computer displays is RGB. It's an initialism for red, green, and blue. In this scheme, binary encodings represent the color each pixel in the image has. Take a look at the top line of bits on this slide. These numbers describe the levels of illumination for each of the 3 lights within the pixel. In other words, the amount of red, green, and blue. And by representing colors using binary numbers, we can manipulate the bits mathematically in order to transform the digital image. For instance, what would happen to this pixel if we doubled the binary value representing the color red? The first 8 bits. If we did that, we'd get a redder color. If the binary code for green, which is the middle 8 bits, were set to 0, and the values for red, the first 8 bits, and blue, the last 8 bits, were set to equal each other, what color do you think we'd have then? Purple, because red and blue mix together to make purple, at least when we're talking about light. What do you think this is, though? Take a look at it. A good long look. What do you think it is? Well, most likely, you're not going to be able to figure it out because the data was misinterpreted. What do you think this is, though? These are the same file. This and this are the same file, but they're interpreted in two different ways. The first program interpreted the bits in the file as ASCII text. The second program interpreted those very same bits according to the rules for displaying pixels in the JPEG format. Remember that bits on their own have no inherent meaning. It's how they're systemically interpreted that conveys information. Imagine that the first few bits of an image read 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Well, that was fun. Imagine that the first few bits of an image file read that. What do you think the computer does with them? What does it interpret them to mean? The application processing the file must be instructed as to how the bits should be interpreted. This can be done by specifying a file extension like .jpeg or .text, or by designating the first few bits as indicating the type of file. It's in the header. However, the important point is that there's no real difference between bits designated as text or bits encoding images, audio, or computer instructions. Bits are just an abstraction. Anyway, guys, I hope you enjoyed this video. I hope it taught you a little bit about pixels and RGB. Anyway, guys, I guess I'll see y'all in the next video. Y'all take it easy out there.